Good afternoon. Today we are going to be working on how to find the constant of proportionality from a table. And this aligns with IXL assignment LKZ. So remember that when we are dealing with proportional relationships, they have a constant of proportionality, and that's represented by the variable k here. And we can see it in parentheses in our little graphic on the left, and then we can also see it in the text on the right. Our main focus is going to be finding the constant of proportionality from a table. When we are doing that, in order for something to be a proportional relationship, there needs to be a proportional relationship between the y and the x values. So in our table of values, we can easily do that by finding out what the pattern is by taking our y value and dividing it by x. And then if it is the same all the way down, it represents a proportional relationship. And we have found that exact constant of proportionality. All right, I think it's best to do this through examples, so let's not wait any longer. Let's go ahead and hop on over to IXL so you can see exactly what I mean, but make sure you at minimum have this down in your notebooks, that k is equal to y over x, because that's what we're going to be using in all of our problems today. All right, here we are on IXL. Remember the code is LKZ. Find the constant of proportionality from a table. So our first problem here says, every Sunday, Devin and her cousins get together for brunch. This week, Devin is in charge of making fresh squeezed orange juice. There is a proportional relationship between the number of oranges Devin squeezes X and the amount of juice in ounces she makes Y. And here we have our table of values. We want to find the constant of proportionality, and our answer either needs to be written as a whole number or a decimal. So in this case, we are told that there is a proportional relationship. This is nice because it means we don't have to find the constant of proportionality for every single line in the table, because we are told already, hey, it's proportional, which means you can just choose any of the lines in the table to find that constant of proportionality, to find that k. So our constant of proportionality, our k, let me change colors here actually. We can find that by taking our y value, which in this case is ounces, and dividing that by our x value, which is oranges. So if we just want to use the first line in that table, we can. We'll take our x value of 6 and divide that by the corresponding x value, which is 2. And then we just need to divide out. We need to simplify our fraction here. So what is 6 divided by 2? That would be 3, meaning our k, our constant of proportionality, is 3. Devin here will get 3 ounces of juice for every single orange. I'm going to go ahead and just on this first example only, do it with another line in the table to prove to you that when you already know it's proportional, you can choose any of them, because you know that if it's proportional, every single one is going to have the same relationship. So if we just take the last line here in our table, we would take our y value of 18 and divide that by the corresponding x value, so that matching x value of 6, and then simplify that fraction, divide it out. What would be 18 divided by 6? That would be 3, which is the same answer we got earlier. So there you go. Question number 2. Jasmine and her dad share an intense love of baseball. Every weekend, they go to the batting cages to practice hitting. Jasmine's dad buys tokens for her to use in the batting cage. There is a proportional relationship between the number of tokens Jasmine uses X and the number of pitches thrown by the pitching machine Y. Here's our table, and we want to know what is the constant of proportionality, and we have to write our answer as a whole number or a decimal. So remember that to find that constant of proportionality, to find that K, we need to take our Y value and divide it by our X value. And once again, they told us that it is a proportional relationship. That's going to be the case for this entire assignment. We're just working with problems that are proportional and specifically finding that constant, specifically finding that K. So if I just use the first line in my table again, creature of habit, that's typically what I do. We have our Y value, which would be 28 pitches. And we are going to divide that by our X value of 2 tokens. So what is 28 divided by 2? That would be, let's fix that. That would be 14. And that is a whole number, so we don't need to do anything else, meaning Jasmine is going to get 14 pitches for every token that is put into the pitching machine. What I just told you, I guess, is wrong. When you get into the higher SMART scores, you are going to have to make a decision. You are going to have to determine whether or not it's a proportional relationship. So at the beginning, it tells you it is. Once you get a little bit later, you're going to have to make that decision. So let's look at this one here. Joy is a tech geek and loves her new smartphone, but she is frustrated by how slowly the battery charges. After coming home from school, Joy notices that the battery level is low, so she plugs her phone in to charge the battery. The table shows the relationship between the total time in hours that Joy charges her phone X and the battery level as a percent of its full capacity Y. According to the values in the table, do X and Y have a proportional relationship? So remember, in order for something to be proportional, every line on that table has to have the same constant of proportionality. So we can do just like we were doing earlier, only we are going to have to do it several times to make sure it's the same throughout. And I'll show you a couple ways about doing this so you can figure out what works best for you and how you process things. So remember that our formula, I'm going to write it up a little bit higher so we have more room, is if it's going to be proportional, to find that constant of proportionality, to find that K, we take our Y value and divide it by our X. So for the first one here, I'll take that Y value of 15. Oops, wrong colors. That Y value of 15 and divide it by our X value of 1. And 15 divided by 1 is 15. Now let's do the same thing for the second table, because in order for this to be proportional, they all need to end up having an answer of 15. So for the second one, we take 25 and we'll divide that by 2. And what is 25 divided by 2? That is 12 and a half, 12.5 when you take 2 and divide that into 25. Is that the same answer as we got earlier? No. So that right there tells us that these are not a proportional relationship. On the next one, I'll show you another way to do it, since this one turned out to be a no, because we got to the second one. It was pretty obvious. We don't need to go any further because we got 2 very different answers. If I double check my work here, 15 divided by 1 is 15. 25 divided by 2 is 12.5. They're not the same, so this does not have a proportional relationship. All right, let's try this one out. Lorenzo loves to read and discuss books, so he joined a book club. The first book he read as a member of the club was a novel set in ancient Rome. This table shows the relationship between the time Lorenzo has spent reading the novel in hours X and the number of pages he has read Y. According to this table, do X and Y have a proportional relationship? So that formula to find our constant of proportionality is K. And remember, we take Y divided by X. So we need to see if they all have the same ratio, because that'll tell us whether it's proportional or not. So for our first one here, we'll do 20 divided by 1, Y divided by X. And that gives us 20. For our second one here, we'll do Y divided by X, which means we have 60 divided by 3. And that also gives us 20. So it's looking good. We need to check the other 4 to make sure. Let's go ahead and check one more using this same strategy, and then I'll show you another way you could check it. So now we have 80 divided by 4. And 80 divided by 4 is in fact 20. All right, you could do this same pattern for the last one. You could take 100 and divide it by 5. And if we did that, we would, get the answer of 20. Another way to do it is once you find what you think the constant of proportionality is, now let me erase some stuff on here so we can see it a little bit better. Once you do that first one and you say, okay, 20 divided by 1 is 20. That means we need to have a ratio of 20. We need to have a pattern of 20. So if we look back through here, 1 times 20 is equal to 20. 3 times 20 is equal to 60. 4 times 20 is equal to 80. And 5 times 20 is equal to 100. So that's another way you could look at it and say, yep, there is a proportional relationship because each row is being multiplied by 20. That is constant. That is all the same. So yes, sirree, it is in fact proportional. And once you say yes, it pops up with a part B that says, what is the constant of proportionality? Well, we already found it because you have to find it in order to determine if it's proportional. So not really any extra work. We just need to type in our answer of 20, that proportional relationship is 20 pages per hour. All right, it is now your guys' turn to try this out. So hop on to IXL. Do remember that IXL has a video that you can watch as well. So if you'd like to see another example, you can watch that before you start. It can be helpful to, hear it from another voice, hear it again. If you need anything, make sure to reach out and ask for help, but I believe you guys can do this. See ya.